And so if we take a look at what we're going to really be talking about in this lecture and in this web application course is the technologies, the different technologies that are used to, in effect, produce a web page, right? So we have a web page over here. You go to URL data.pr4e.org/page1.htm, and here comes a page, and this is like a super simple page. But there are so many technologies, like how browsers work with JavaScript and jQuery and CSS and eventually Vue and things like that. That's a whole set of front-end technologies, and then there's sort of back-end technologies like Django or Flask and databases. And we're gonna learn in this. My focus in this class is less about how to make it all look beautiful, although that's important, and more about how to deal with the back end. So what we're going to see is these technologies that define the look and feel and the interactivity of your web pages, but also then how data and HTML, CSS, and JavaScript are served up by the remote server. And so the internet here is in the middle. The browser is sitting on your laptop or your phone or whatever, and it has all these technologies built into it. It makes requests, and then the server comes back with responses. And so the simplest version of this protocol is that you click on a tag, and when you click on that tag, you get a new web page. Now, if you watch your debugger console, you will see that sometimes it's 120 different request response cycles used to construct the page. But in a sense, they're all the same. Now, as we move to things like HTTP2, there are ways to pull down multiple documents in a single connection, but we'll stick with the old HTTP1 way of thinking about it. In the simplest form, the browser asks for a document and then retrieves the document and then shows the document, and that is the basic request response cycle. So if you look at how this works, that browser is an application running inside your computer on your laptop or your phone. That is a piece of code. And in that, it's got a connection to the screen or the keyboard or the mouse or whatever, and it's watching for events, meaning that you're going to go and you're going to click somewhere, and then this application is going to respond to the events. So in a web page, in the simplest case, you got stuff that you can click on and stuff that you can't, and you go find your way through whatever to click on part of that web page, and that click is intercepted by the application, whether it's Chrome or Firefox or Safari, running on your piece of equipment. And then that application then opens what's called a network socket, a socket across the network to a web server, and sends a request. And that request, as we'll see in a bit, is a specially formatted request. It has a GET command, and then it has the URL that it wants to get from the web server. And then the web server does a bunch of work inside itself, maybe reading disk files and running programs, generating what it is that you want, and then it sends the response back on that same socket connection. So there's like this socket connection through which all of this stuff is viewed. And so the HTML is the basic thing that comes back. As we go further, we'll see that it's not just HTML that comes back, but other things as well that come back. And so when the browser receives that HTML, then it says, oh, I know what HTML is. I've got this header 1 tag. Here, let me change the color of this thing so you can see it a little better. Yellow is way better. Okay, so when the browser receives this page, it sort of sees it and it looks at it, and then it looks at all the HTML. And so part of this course is to understand the syntax of HTML. That itself is how to build good HTML and CSS and how to make it look beautiful. But ultimately, something in that HTML plus its CSS plus its JavaScript leads to a visual display of the page, and then that's the thing that you see. And so this is the request response cycle. So up next, we're going to talk about what these network sockets are, or the things that fundamentally underlie this request response cycle. So network sockets are like phone calls for computers, and literally in the 1960s, when they were designing the concept for network software, that is the concept that they came up with. And that is that, in a sense, we make a call, we talk on the call, and we hang the phone up. And as computers were going to share data, and some computers were going to have data, and other computers were going to want data, they thought, oh, the way to do this is not necessarily have a permanent connection to that data, because there's going to be so many computers and so many sources of data and so many computers that want to consume those data. And of course, in 1960, they had no imagination that there would be billions. They just thought there would be 10,000, and they thought that was a lot. But they came up with a protocol that basically said, when you don't have continuous permanent access to data, you actually make a phone call, you know where the data is at, you kind of say, you dial up, you grab the stuff, you get it back, and then you let the connection go. And so it means that with billions of computers, each talking to each other, the network isn't so complex. And so there's this connect, talk, disconnect. Connect, talk, disconnect. And it's the way the phone system in our world scales to all the people, and it's the way the internet scales to all the people that want to use that internet. So this is made inside of software using an abstraction or library called sockets. And sockets really are computer phone calls. You know where you're going to call. You can start the call, wait for them to answer. Once they answer, there is a two-way communication. It's kind of like a file, except that you can simultaneously read from the file and write from the file. Although it's important for the two cooperating pieces of software to know who's going to read first and who's going to write first, because it's like if, when you pick the phone up after it rings, we all know to say, hello. And that's kind of a protocol. Who talks first is a protocol. And then the person goes like, who is this? And then eventually conversations happen pretty naturally. Somebody talks, listens, someone else talks, listens, and that works. But there's complicated protocols. And you can think of this not necessarily as the browser on your laptop or phone as talking to data on the server. It actually is talking to another program. And so even when it's just retrieving a file, it's talking to an application on that server, and that application is reading the file and sending it out. And we'll see that eventually, how we have to do that when we're doing things like uploading pictures. We upload pictures and then we have to actually serve them back out. We can't just say, oh, the pictures are there, you can grab them. Because sometimes not everyone can see every picture. And so part of the software application decides, if you are allowed to see this picture, I will send it. If you're not allowed to see the picture, I will not send it. And so that's where it's a piece of software that you're talking, even if you're looking at a picture. Sometimes that software is really simple and you barely notice it, but there is software in the loop. It's not like you just go straight to data. It is really two pieces of computer software talking to each other, and we use the internet as that intermediary to allow that conversation to happen. So if you read my book about the TCP/IP, you'll learn this in super great detail, but every computer has an IP address. It is a number. There are two kinds of addresses. There's IPv4 and IPv6. IPv4 version 4 is the one that's got 4 dotted numbers, like 142.16.42.14. But within each of those, they have what's called a TCP port number. And because this whole internet thing is applications talking to applications, we need to have a good way to know which application we're talking to. And that's where TCP port numbers come in. And you can think of this as like a phone extension. So you have a phone number and then you have, extension 1436. And so TCP port numbers are like that. So we can not have a specific address for every application, but an application that has an address and a port within that address, or a phone number and an extension within that phone number. And so you can look these things up. Port 25 is used for email, server-to-server communication. In the old days, we used this thing called Telnet. We'll talk about that on port 23. And so the client is on the right-hand side, and it might be a computer where you've got a keyboard and it's you, or it might be a server that's got some mail that's being forwarded from somewhere, and they all talk and they connect to an IP address. In this case, 74.208.28.177 is the IP address of this computer, and then port 25 is the extension where one computer sends email to another computer. And each of the arrows in between them is a separate protocol. So if you're talking to an email server, you expect to talk an email protocol. And if you're talking to a login server, you have a login protocol. That's kind of the simplest one. Or a web server, Web server can be on port 80 if it's unsecure. Preferred, of course, is HTTPS, which is on port 443. If you have a mail application like, say, Thunderbird that's reading Gmail, it talks to ports 109 or 110 or a couple of other ones that are ways for a mailbox application to talk a protocol to a server-based mailbox to retrieve the new messages or delete a message or view a message or whatever. So there are these ports on servers that have protocols, and then we can build software on our clients that talk these protocols. The one we're going to be playing with the most in development mode is port 80, and in production mode, port 443 for the HTTP for web documents, basically, and web application documents. So up next, we're going to take a quick look at the Hypertext Transfer Protocol. I always want to call it Hypertext Transport Protocol, HTTP, and that is the protocol that we talk to port 80 or port 4. Hypertext Transfer Protocol is the protocol that browsers use to talk to servers. Now, we've used it for all kinds of other things because it turns out that it's a super simple and super elegant protocol. Now, this goes to a long time ago. This protocol was invented in 1990, which is like going on 30 years ago. Yeah, going on 30 years ago now, or more. And there were many protocols. You would have one piece of software and there was server software and client software. You had to match them up, and then you talk to the right port with this server software. And one of the inventions of Tim Berners-Lee and Robert Caillou at CERN was that we came up with this notion of, instead of lots of pieces of software, we would have one piece of software called a web browser, and it would be multi-protocol. And so we have this thing called the URL, or Uniform Resource Locator, and we just sling these around. We just use them. But these things, this was itself an amazing innovation in 1990, because in the old days it'd be like, use this piece of software and talk to this address. So the URL captured three really important, very separate things. The first thing it did is it allowed for multiple protocols. Now, the one that you mostly have seen is HTTP or HTTPS, but that's a protocol. FTP : or mail-to : might be the other ones that you've seen. And then a host, and then a document. And that host is a domain name, which is a nice symbolic way to get a server address. And that eventually resolves to an IP address like 141.206.14.22 or something. And then the document within that server, and that /page1.htm is the document in the server. And I'm just saying, before 1990, there were many protocols and we did many things. But after 1990, this one protocol, HTTP, found its way into so many awesome solutions that it's by far, other than email, the dominant protocol that we use on the internet. Like I said, it was invented at CERN by Tim Berners-Lee and Robert Caillou to retrieve documents and images. And as soon as they built it, because it was all the other protocols that came, most of the other protocols were kind of complex, because we're computer scientists and we make complex things and we love complex things, and we're very, very good at complex things. But this was, when the web was being built, Tim and Robert were not like, we're going to make the greatest thing ever. We're just going to make a simple thing. So they made a simple thing, but it turned out to be the greatest thing ever, because different engineers would be like, oh, wow, I can use that a little different way. And it was, the grounding of it was super simple. And the basic concept was, you connect to a server, you figure out where it is, you send a single command with a bit of extra data, and then you get back something, a document. It could be an image, it could be data, it could be HTML. And it was really amazing, right? And so the sockets, the underlying sockets, are the things that make the phone call. HTTP is what we do once this phone call has been established. So one of the things that made the internet so successful starting in the 1960s was a radical openness, we're all around the same campfire feeling, very friendly, respectful, that still allowed criticism. There wasn't like one super genius that designed this or one company that designed this. This was a collaboration. And the collaboration was around a set of open standards and meetings to help build these standards. And they were called RFCs. They were called Request for Comments. And there was a group that built these called the Internet Engineering Task Force, the IETF. And the The request for comments is a fun notion. We're looking here at a September 1981 document, which is 40 years old about now, and it's called a request for comments. And the idea is, as engineers, we might have a design that everyone thinks is the greatest thing ever, but we should always question. No design is perfect. No design is beyond question. No design is beyond commentary. And so even when they're 40 years old and used worldwide and dang amazing, we still say there is room for improvement. And so this talks about, I think this one's IP, and there's an IPv6. There's another one. If you look for this RFC that we're looking at here, there'd be IPv6, and you'd start reading it. And it's pretty dense reading, but as an engineer, it gives you all the details to build a router or build a piece of software or build whatever. And these are 100% public documents. And the idea is that no company, because literally the companies that were around in 1960, if they had said Burroughs or Sperry owns the internet or Digital Equipment owns the internet, they're all out of business because they didn't make good choices, but the market was able to make good choices. And because the commons were these open standards and open specifications, new companies like Sun Microsystems and new operating systems like Linux could come in, and even Windows could come in and participate as full participants because they just read these specs and all of a sudden they're interoperating with everybody else. This is fundamental and foundational to how the internet works. And I'm not saying you're supposed to go read them, but it's just fascinating to understand that the entire technological infrastructure upon which the internet is built is free, license-free, royalty-free, and you could build a brand new gadget and you could hook it to the internet by reading these specifications. You don't have to pay a developer's license or nothing. It's cool. Sorry, I'm just a little bit too excited about that. So let's take a look at one of these in particular. Now this is probably supplanted, but we'll look at RFC 2616. They go up in numbers, and so this is HTTP, Hypertext Transfer Protocol. And if you wanted to build a web browser or a web server, you could read this document. Go ahead, read the document. And if you read down far enough, you'll say, oh, this is how you make a request. Blah, blah, blah. It's got a header, and it's got like a carriage return line feed, and then a message body, and you got to do this, and this is what it looks like. This is how it works, right? And so at some point, you're deep in this document, and you're finding out in this page right here of this document how your browser is supposed to format it. And this tells both the client and the server what the rules of the protocol are. Now, it's a lot easier for me to tell you. So you connect to the server on a socket, usually port 80 or port 443, and then the client is supposed to make the first sound. It makes first request. It sends a line with a carriage return line feed at the end that has the characters. There's other ones, but get, GET, space, a URL, space, and then a protocol. And right now I'm using this HTTP 1.0 because I can do it by hand, right? And so you ask for a document, and then you can optionally send some header information, things like what language this person at this browser prefers, what are the capabilities of this browser, what version browser we have. So there's a series of things. You say, give me this document, and here's something about the browser that's requesting the document, including information like cookies that are being said. Now, so this, in case you want to know who is doing this request because you've logged somebody in and set a cookie to indicate that they're logged in, that's all sent on this GET request. But we'll not send the headers. There's actually incoming headers and then outgoing headers. We'll see these when we start looking at Firefox's debugging console. And so this is an entire interaction that you can do on your laptop. Now, I'm not going to do it for you, but I would note that the program Telnet that this uses has been removed from most computers. It makes me sad. They think of it as a security hole because it doesn't use encrypted connections. Like port 80 is not an encrypted connection. But ultimately, you can install, go search on your favorite search engine and find out how to install Telnet. But if you get in a command line, whether it's a Windows command line or a Mac command line or a Linux command line, and you get Telnet properly installed, you can type the following command: telnet datapr4e.org 80, and then hit enter. And at that point, so telnet originally was used to log into computers, but if the server we're talking to and the protocol that we're talking to is simple enough, and in this case HTTP1 is simple enough for us to be able to do this, we're actually talking to the server, because remember I said that these are applications. They're not, your browser is not talking to files. Your browser is talking to an application on a server, and the server might give you back a file. So it's really talking to a piece of software, and we'll see this in more detail in the next section. And so what will happen is, because the HTTP protocol requires that the client speak first, we have to type. Now, if you can get this working and type wrong things, and type a couple enters, new lines, you will see that you're talking to a piece of software, and it will say, "You have violated my protocol." You're not talking to a thing that has any online help or user interface or anything like that. You're talking to a server, and your job is to request some data using the proper format because you read the specifications about the proper format, right? So in this particular one, it's easier to cut and paste this, because some of these servers, if you don't type fast enough, they'll be like, "You're not a software, you're a human, quit playing with me." Like if you talk to Facebook or something, and you can talk to Facebook and see what happens on port 80, and it will time you out really fast. So it's good to have a cut and paste buffer. So you paste this get command in, and the other thing that's important is you got to put an extra blank line. And this extra blank line is to indicate that you're not going to send any of those headers. If we were going to send things like what language we would prefer or what formats we would prefer as a browser, the browser has certain languages and other configurations and login information, and that can get sent up to the web server along with the request for the document. And we would be able to type them in here. But we're not going to do that in this very simple. We're just going to say enter, which means no more headers. If you were putting in headers, you type header, 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 and then enter on a blank line, and then the server would know that our request was finished. But we can just ask for a page, and then what the server does is it sends us back two pieces of information. First, it sends us headers. The first header is HTTP 1.1 200 OK. That's actually a status line. Now you'd have to go read the documentation on what that works. But for example, 200 means that you got a document. Another one that you might have seen is 404. It might say 404 not found. So if you go to a web page and it doesn't exist, something will say 404 in your browser, usually, unless it says, "Here's a search box, go find it." But there's a status, and so the thing that you're typing, page1.htm, may or may not be on this server. If it is, then you'll get a 200 OK and the data, or you'll get a 404 not found. And then we get some response data, some header response. And this header response looks pretty much like the same format of the data we would have sent into the browser if we were sending things like that in there. Here it's what the date is, what the server we're using, last modified. And one of the important things is what kind of content are you about to see. Content type, in this case, is text/HTML, which means the thing coming next. And then there's a blank line. And the blank line is our indication as we're reading this data that we've finished the header, which is really metadata about the page we're retrieving, and the actual page itself. And so the rest of this page is the actual data, and we know the format of it because we were told before the page starts. This could be image/PNG. This could be XML, application/XML. Then it could be JSON. It could be like anything. And then the browser is supposed to, and if this was an image, it would be like garble, 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 right? It would be all garbled stuff that we can't really see, but the browser knows what a PNG or JPEG looks like, and it shows it to you. And it basically uses this text/HTML to tell you what's going on. And so then your browser has read all this information. It has both the metadata and the data about the retrieved page, and then its job is to sort of produce a pretty rendered version of the page and show it to you. And that is the request response cycle. Again, you don't have to do this. You can just sort of believe that it's done here. But if you want to install Telnet on your system, it's not a bad thing to install Telnet. It's kind of a classic, fun thing. It's far less useful than it was in the early days because we used to use Telnet to test everything. Now we've got like browser developer consoles that are way easier than Telnet. But it's kind of a cool thing. Feel free to do this, and you'll be like, I know what's really going on. And so I'm a big fan of using the console, of using the terminal, of using text-based interfaces. I think they're actually way more accessible. I think it's awesome. And in a way, all these fancy graphical user interfaces distract us from the simplicity of what's going on inside of computers, because you think, well, where's the button? And the answer is, oh, there's probably some command inside this computer that does what the button does. So I have a former student of mine who actually wrote the scene in, I think, maybe it was Matrix 2. I think this was Matrix 2. Yeah, Matrix Reloaded. And this scene where Trinity is breaking into the power grid and she is using the console. And it turned out that the way this scene was written is it was written exactly as a hacker, whether that's a hacker with bad intent or good intent, because there are hackers with good intent who are trying to break into your system so they can tell you, you pay them to break into your system so that they can tell you your vulnerabilities. But you can take a look at the analysis of this little scene, and just this sort of is just one of the cool things about me teaching people about how to use the command line, and increasingly me teaching people about how to use Linux. I really think that it's okay to know your Mac and Windows command line, but really increasingly the world in the server world, and we're starting to work on web servers in this class, and you might as well start learning some Linux, because that's an important skill. Just writing some Java code or Ruby code or Django code, that's a skill, but knowing how to start the server, debug your application, find log files, etc. in the command line is really important in real production systems, because we're going to play in some simplified environments to make it a little easier, but those simplified environments go away once you go into real production in a real job. And so I'm really into teaching you Linux, command line, etc., etc. So up next, we're going to show you in Python, in effect, as few lines as I can possibly show you, how a browser works, how a browser sends the HTTP protocol, how a server reacts to the HTTP protocol and returns documents. So that's what's coming up next.